So guys, now we're going to do a chapter 7 summary version 2.0. I hope you know and learn from something from it, and let's go. So guys, chapter 7 IP addressing. So the objective of this chapter 7 is explain the structure IP addressing and demonstrate the ability to convert between 8-bit binary and decimal numbers. Given an IP address, classify it by type and describe how it is used in the network. So, explain how addresses are assigned to networks by ISPs within network by administrator. Determine the network portion of the host address and explain the role of subnet mask in dividing networks. Use common testing utilities to verify the test network connectivity and operational status of the IP protocol stack on the host. So before we proceed to the summary, we're going to make a short run about the what is inside of chapter 7. So first the introduction, second the IPv4 network address, next is IPv6 network addresses, and connectivity verification, future of networking, and then we go to the summary. So first, there are binary notation that refers to the fact that computers communicate in ones and zeros. So converting binary to decimal requires understanding of mathematical basis of number system and notation. So in this chapter they are teaching us on how to convert binary to decimal and decimal to binary. So IPv4 unicast, broadcast, and multicast. First, the unicast. Unicast of IPv4 is the process of sending packet from one host to individual host. So the next one is the broadcast, the process of sending a packet from one host to all hosts in the network. And multicast transmission is the process of sending a packet from one host to a selected group of hosts, possibly in a different network. There are also the private address blocks. So hosts that do not require access to the internet can use private addresses. So it can be 10.000 to 10.255, subnet 255.255. Next is 172.16.0 and next is 192.168.00 and 192.168.1255.255. So shared address space addresses, not globally routable, intended only for use service provider networks. Address block is 100.64.00. So special use of IPv4 address, network and broadcast address, loopback address, link local address, and testnet addresses and experimental addresses. So there are also in legacy classful addressing, classes addressing. So formal name is classes, interdomain routing, CIDR, pronounced as CIDR. So assignment of IP address, regional internet registers are RIRES, the major registries are. So there are also need for IPv6 guys. So IPv6 is designed to be the successor of IPv4, which is now happening. So IPv4 has a theoretical maximum of 4.3 billion address plus private address in combination with NAT. It is much larger 128-bit address and space providing of 340 undecillion address, and also fixes the limitation of IPv4 and include additional enhancement as ICMPv6. So the dual stack, the tunneling method that IPv6 packet and IPv4 packet encapsulated inside an IPv4. So there are also hexadecimal number system. Hexadecimal is the base of 16, and 16 numbering system uses number 0 to 9 and A to F. So address of representation 128 bits, choo. So rule number 1, omitting leading zeros. The rule number 1 is, first rule to help reduce the notation of IPv6 address is any leading zeros in any 16-bit section of hex that can be omitted. So the rule number 2 is a double colon can replace any single contiguous string of one or more 16-bit segment or hex that's consisting of all zeros. So IPv6 address, there are types of IPv6 address: unicast, multicast, and broadcast, and anycast rather. So IPv6 length, IPv6 types, and IPv6 unicast addresses. So IPv6 global unicast, it is similar to public IPv4 address. It also global unique and internet router routable address and can be configured statically or assigned dynamically, and link local used to communicate with other devices at the same local link. So there are also loopback, unspecified address, unique local that is similar to private addressing, and IPv4 embedded, not covered in this course. So there are also structure of IPv6 global unicast in the chapter 7, and global routing prefix, a prefix that portion of address assigned by the provider such as ISP to a customer or such currently RIs to a subnet ID and interface ID also is in there, used by organization the subnet ID to identify subnet within its sites. So there are also dynamic configuration of a global unicast address to using DHCP-v6 and AU64 process or randomly generated, and link local addresses or dynamic link local addresses are also explained in that chapter. So there are also solicit node IPv6 multicast address. So there are always multicast prefix and least significant 24 bits. So now there are also ping, the trace route, and the testing path. So guys, now in this summary, now we proceed to the summary. IP addresses are hierarchical with network, subnetwork, and host portions. An IP address can represent a complete network, a specific host, or the broadcast address of a network. So guys, it also address the authorities and ISPs allocate address ranges to users who in turn can assign this address to their network device statically or dynamically. So the allocated address range can be divided into subnetworks by applying subnet mask. So the private IPv4 address blocks are, as I said earlier, 10.000.8 and 172.16 and 192.168 and 0-16. Next one is each IPv6 address has 128 verse and 32 bits on IPv4 address. There are three types of IPv6: unicast, multicast, and anycast. So IPv6 does not use the dotted decimal subnet mask notation. The prefix length is used to indicate the network portion of an IPv6 address using the following format: IPv6 address / prefix length. So the next one is packet with a source or destination link local. Address cannot be routed beyond the link from where the packet originated, and once implemented, an IP network needs to be tested. So guys, that is all for this video, chapter 7 IP addressing. And again, I am Mathew, and that is all, and thank